because I think AI is intrinsically a sci-fi concept. I love the concept of AI in the context of science fiction and philosophy, but I feel the term itself is a problem if we're talking about engineering. You can't build something if you can't define it concretely. So when we call things AI, basically, I think we're going to always have AI winters so long as we call it AI.
Good morning, good afternoon, or good evening, depending on where you're listening. Welcome back to AI and the Future of Work. Thanks again for making this one of the most downloaded podcasts about the future of work. If you enjoy what we do, please tell a friend. And we'll keep sharing great conversations like the one we have for today. I'm your host, Dan Turchin, CEO of PeopleRain, the AI platform for IT and HR employee service. We learn from AI thought leaders weekly on this show. And of course, the added bonus, you get one AI fun fact each week. Today's fun fact, Kyle Wiggers and Devin Coldaway write in TechCrunch that AI ethics keeps falling by the wayside, in which they share the disturbing update that AI image generators, including Stable Diffusion and Imagine from Google, were trained on the LAION, it's the acronym LAION, dataset, which contains thousands of images of suspected child sex abuse. The Stanford Internet Observatory reported the links to law enforcement. As a result, the nonprofit LAION is pledged to remove the offending data and has taken down the dataset. My commentary, as we've seen from recent high-profile failures by Bing Chat and Google Bard, it's almost impossible for LLM owners to anticipate ethical issues and potential problems with their models in advance. AI regulation is a starting point, but as an industry, we need to be much more proactive to design and implement the right guardrails. One approach is using AI to monitor AI, but for the foreseeable future will require large teams of humans to thoroughly test models against industry-accepted benchmark test sets. As always, we'll link to the full article in today's show notes. Now shifting to this week's conversation. Dr. Eric Siegel is a leading consultant and former Columbia professor who helps companies deploy machine learning. He's the founder of the long-running Machine Learning Week conference series, executive editor of the Machine Learning Times, and a frequent keynote speaker. He wrote the best-selling Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die, as well as the AI Playbook, Mastering the Rare Art of Machine Learning Deployment. At Columbia, Dr. Siegel won the Distinguished Faculty Award when teaching graduate computer science courses in machine learning and AI. Later, he served as a business school professor at UVA Darden. Eric has appeared on Bloomberg TV and radio, BNN in Canada, Israel National Radio, National Geographic Breakthrough, NPR Marketplace, Radio National in Australia, and The Street. Eric and his first book have been featured in Businessweek, CBS Money Watch, the Financial Times, Forbes, Fortune, and others. I could go on all day without sharing Dr. Siegel's full bio. But without further ado, Eric, it's my pleasure to welcome you to AI and the Future of Work. Let's get started by having you share a bit more about your background and what got you excited about this space.
Well, thanks, Dan. Thanks for having me on the show. I've been in the field of machine learning for more than 30 years. I was a professor at Columbia University, where I also got my PhD, teaching graduate level courses in machine learning and AI. And I've been a consultant applying machine learning for business applications for 20 years, during which I founded the Machine Learning Week conference series you mentioned. We've been running that since 2009. My original interest, came from the childhood fascination with the concept of AI. Having said that, I've become much more of a pragmatist. So I'm really into the concrete business value of enterprise machine learning, and quite concerned about the way the term AI is thrown around and conveys a certain kind of hype.
What inspired you to write the AI Playbook? Who are you writing it for?
Well, the book's for anyone involved with machine learning projects, whether a business stakeholder or a technical data scientist. And the reason I wrote it is that until now, there's been no established standard practice, framework, playbook, paradigm, a business practice well known to business professionals for running machine learning initiatives. And as a result, most new machine learning projects at most companies actually fail. They fail to successfully reach deployment. So what I present in the book is exactly that. A standard business practice that I call BizML consists of 6 steps meant to usher machine learning projects successfully end to end from conception to deployment. But let me say that, the bigger point of the book, beyond sort of stepping through that practice, is the following. Business professionals, the non-data scientists, have got to ramp up on a certain kind of semi-technical know-how and knowledge about how machine learning works and how it delivers value. In particular, they need to learn 3 things: what's predicted, how well, and what's done about it. And that really defines the project. They need to get involved, dig down to those details. It's not the rocket science part. It's about how to make use of and capitalize on machine learning. And only by becoming familiar with that knowledge, it's totally accessible, fascinating stuff, can they then, in an informed way, can you participate in and collaborate deeply with the data scientists. And that's the only necessary process by which the end-to-end project will succeed and reach a successful deployment.
When you write a book, there's always some interesting anecdote or insight that gets left on the cutting room floor. Love to know, what's something that surprised you or that you learned while doing your research that we won't learn about in the book?
There were a couple things. One is, I used FICO as one of the main examples in the book, but focused on their fraud detection. And did you know that, although they're very well known for their credit score, everyone's familiar with their FICO score, that perhaps a bigger part of their business is for payment card fraud detection. And their model that they develop over a tremendous amount of data across banks, and then deliver as a product to most banks, is used in real time to screen payment card transactions, ATM cards, debit cards, for 2/3 of the world's cards, 90% in the US and the UK. Every transaction in real time, their model is used to determine, hey, what are the chances this is a fraudulent transaction? And then the bank uses that to decide, should I authorize the transaction or should we hold it as potentially fraudulent? And that's a really big, perhaps more important or more significant piece of FICO's business, but it's the thing that affects you much more often, but is a much lesser well-known aspect of their business.
It's a fascinating topic. Very few people understand FICO. Loyal listeners of this podcast do, though, because we had the chief analytics officer from FICO, Dr. Scott Zoldi, on as a great guest in season 3. I'll put a link in the show notes, but it really is an amazing organization. And
that's awesome. So Scott will be keynoting at our conference, Machine Learning Week, first week of June in Phoenix, once again. And he was my main source of content for a good portion of especially one of the chapters on data preparation from the book.
I'm sure it'll be a great keynote. And this was not intended to be an ad for the event, but go check it out. Scott is a great speaker. He's a really dynamic person in his community. We talk about generative AI, and you and I are kind of in the cradle of Silicon Valley. We've all been hyperventilating for now more than a year about generative AI, but I know a lot of your research in your past is related to what we'll call classical machine learning. What are the right ways to determine when, quote, classical machine learning is a good fit for solving a data problem, and then where is generative AI the right approach?
Yeah, I mean, they're kind of apples and oranges. And so I've been hyperventilating for a year about how much everybody's been hyperventilating, because I believe that although it's extremely amazing and I'm excited, the world's maybe 10 or 20 times too excited, in my opinion. But there is value. It's very different. I like to call the established enterprise use cases of machine learning predictive AI, or to differentiate it from generative or predictive machine learning, or predictive analytics. That's fine. And that's what it was called for a while. That's the title of my first book. Rather than classical, because that kind of implies that it sounds kind of old school, but it's still cutting edge and it's still growing like mad. In fact, its potential has only been realized a small bit. And of course, the purpose of my book is to get it successfully deployed. There's a lot of excitement about the technology, but it's not getting deployed. So let's contrast and say what the difference is. Well, the predictive use cases, that's where you have the potential to improve your existing largest scale operations. That's where the money is. That's where most of the money is being put by, almost an order of magnitude. Although generative AI is catching up, it's growing probably more at a higher rate. On the other hand, it's not a zero-sum game. These are really apples and oranges. They have very different value contributions. So predictive machine learning applications are to learn from data how to make predictions on the outcome or behavior of each individual, which is often an individual human. In the case of a customer who's going to cancel, who's going to click, buy, lie, or die, as in the title of my first book, commit an act of fraud, turn out to be a bad debtor, cancel their subscription. But it can apply to any other kind of individual level of granularity. Could it be for B2B? It could be a corporate client. It could be which satellite's going to run out of battery, which transaction's likely to be fraudulent. Whatever it is, it makes these predictions in order to drive decisions that pertain to that exact particular individual, to decide who to market to, who to investigate, incarcerate, set up on a date, or medicate. Very much used in healthcare. What's your prognosis? What's your outcome? Are you going to be readmitted to the hospital? Same core technology in order to drive treatment decisions, whether they're clinical treatment or marketing treatment decisions based on an expected outcome. That's what it means. I mean, prediction's the holy grail for improving all the large scale operations we do, because they consist of many, many individual decisions, and the decision of how to treat or whether to interact with or potentially be passive with an individual is based on these expected opportunities or negative outcomes that you're predicting. Now, generative AI, runs with the same core technology, machine learning, albeit perhaps a more advanced form, and it's predicting on a per word basis, more or less, in order to write text, or a per pixel basis in order to generate images. So, although at the core there's a lot of overlap in terms of the technology, what you're getting with generative is it's basically making first drafts, right? That's the majority of potential use cases. You do need to manually review what it's generated. There needs to be very much a human in the loop. So that's sort of, if I'm going to contrast predictive to generative, one of the ironies as we move to generatives, it's so amazing what it does. And I spent 6 years in a natural language processing research group during the course of my PhD, and I never thought I'd see what it can do. I think it's unbelievable. It's amazing. But the irony is that as we move to systems that are more seemingly human-like, as you're doing with large language models, you're actually enabling less potential autonomy. It's in the predictive use cases where there's leniency. You can generally not predict as well as a magic crystal ball, but you can predict better than guessing. Therein lies the value. And you can automate. You can automatically decide whether to authorize a credit card charge. You can automatically decide which of these million prospects to market to and which ones not, which ad to display on the fly. There's so many use cases that can be fully automated, whereas autonomy in generative applications, that's a sort of a big component of what I think is basically hype and poor expectation management, is there's an implication that because it's more seemingly human-like, it's going to become human level. It's going to be able to do things autonomously like any employee. And I think that that's setting us up for disappointment. That's not to shoot down the potential value. Having something write a first draft, for example, of code or of English or whatever is potentially extremely valuable depending on the context and the nature of the task. Just perhaps an order of magnitude less valuable than the valuations we're seeing thrown around today.
I believe that generative AI has captured the public's imagination because it's language first and humans speak language, as opposed to what you're calling predictive machine learning is data first and humans don't speak data. So I feel like it's the first time when as humans, we've been able to hold this technology up in front of us, almost like a mirror, and see a vision of what the future of humanity might look like. And what it might mean to have a colleague that's a bot. And it triggers all kinds of these kind of science fiction notions that are closer aligned with the term artificial intelligence than classical or predictive machine learning. Is that kind of consistent? Sounds like you have more or less the same thesis about the euphoria around generative AI.
Yeah, totally. And my position gets maybe even a little more extreme than that, because I think AI is intrinsically a sci-fi concept. I love the concept of AI in the context of science fiction and philosophy, But I feel the term itself is a problem if we're talking about engineering. You can't build something if you can't define it concretely. So when we call things AI, basically, I think we're going to always have AI winters so long as we call it AI.
You mentioned you've done a lot of work with FICO, and I know there are many other enterprise customers that you've worked with. You're talking to a large audience of practitioners in and around the field of machine learning and AI, academics, investors, who I know are thirsty for examples of what's working in the enterprise. Maybe if you could share another example of an organization you've worked with and what the problem is that you've helped them solve.
Yeah, sure. I mean, I've kind of made bread and butter with the conference series of all the success stories and, the UPS and FICO case studies in the book. I think they first came across my radar as speakers at our conference. In fact, my first book has a central color table of 183 mini case studies, almost all of which came from the conference. In my own consulting practice, I have a couple .com examples in the book, and one's a failure. So why don't I tell you the bad news first? Which is I was doing churn modeling for an online dating site. So churn modeling is a model that predicts which paying customers are going to cancel their ongoing subscription so that you can most effectively target retention offers. Retaining a customer is usually more cost effective than acquiring a new one. So this is a very potentially hot marketing application of machine learning. You can't afford to offer a retention offer to all your customers. That's essentially a discount in most cases. The only recourse by definition is prediction. And that's what the model does. It predicts which customers are at risk or most likely to cancel within some time window, let's say the next 3 months. So this is very prevalent. Most cell phone carriers do this. Banks do it. It's a very prevalent business opportunity. But this is an online dating website, and it, a smaller company, and I sold this concept to them. I'm like, look, this is a great idea. So I pitched it sort of the way I just did, and they said, let's do it. They were doing very well as a business, and I tell this whole story in detail in the book. Anyway, what happened was I made the model, and I'm like, great, I made the model, and we should be able to target a retention campaign. And they said, you want to do what? You want to have a whole new marketing campaign initiative? I'm like, yeah, if you don't act on the model, nothing's going to happen. They hadn't gotten it. So that's one of the main lessons I'm trying, and I'm not the only one who's experienced this. I hear this over and over again from colleagues. Obviously, as most people know, with technology, you need to start with the potential business value, the value proposition, the use case, what you're going to do with it, which in the case of machine learning is what's predicted and what's done about each prediction. In this case, predict who's most likely to cancel and offer them a retention discount or something like that. But so that's just the first, literally only the first of 6 steps is to get on the same page between data scientist and business professional or business stakeholder about that plan. But you need to go a lot further and get a lot more detailed and be involved in the details from end to end as you flesh through pre-production. And that's what the first 3 of 6 steps are. You're establishing what's predicted, how well, exactly which metrics, and then what's done about it, what the deployment is. You're planning for that last step. Step 6 is the deployment. And then just to finish that, what these 6 steps are, the other 3 are the main production steps of any machine learning project, which is prepare the data, train the model, and then deploy it. Then you have to monitor moving forward. But the point of this configuration of 6 steps is at least get to a successful deployment. I talk about monitoring later on in the book after step 6. So what happens is people say, okay, if we have a general gist of, okay, we're going to predict churn and then we're going to try to retain those customers, that's sufficient. And it's not sufficient. But if you get people involved in detail from end to end, then by the time you get to that deployment phase, they won't get cold feet, and they'll be ready to deploy. It'll get triggered. You'll have a successful project. And that general paradigm and discipline tends to be what's missing. The next case I cover in the book is on a client where I help them target ads. And I call the client EduPay. They provide grant scholarship information to 1 out of 3 college-bound high school students. And along the way, they show ads, and that's the way the company generates revenue. So they wanted to target their ads better. Now, I learned my lesson the easy way in this case because I didn't have to come in with the vision and hold their hand end to end about how we're going to have to organize this project, because they kind of came to me already that advanced. They already knew They weren't data scientists, but they knew, hey, this is the kind of thing we want to predict. This is how we're going to integrate it into our ad selection and improve over the existing legacy ad selection. So I kind of won the game by luck in that case. So not only did I once again get paid as an analytics consultant as I had in the first case, but I actually was able to help the client to a successful project. So, and these are glowing examples also from UPS and FICO, where they take an unusually forward-looking approach of not just what's the number crunching, what's the core technology, what are the analytics, but planning from the get-go exactly how it's going to be deployed. It's a business improvement project first and an analytics project second.
One of the things that I think is unique about generative AI, going back to the previous conversation, is because it has the capability of impersonating a human, it introduces a lot of thorny ethical issues. Like I referred to image generation in the fun fact for the week in the opener. We never really had to deal with that when we were thinking exclusively about predictive machine learning or classical machine learning, because nobody confused the output of a model like the ones you just described, for a dating site, predicting churn with anything that was human-like. What's your perspective on this kind of emerging focus on the ethics of AI when it comes to ways that AI can be used to trick or create, a false sense of what a human is to other humans?
Yeah, that's a great question. I think there's a little bit when a language model generates something that's offensive or it tries to talk that New York Times reporter out of his marriage. I think there's a little eggshells thing going on here because look, if something that has a random component is generating language and it's just a machine, if it's going to spit out stuff, we want to ameliorate that if kids are seeing it. But adults are capable of understanding, hey, this thing is operating with random characteristics. I mean, when I was a kid, I programmed in BASIC on my Apple II Plus, random poems, and it would pick from a series of adjectives and a series of nouns and put together refrains, and it was very cute. But when I was 11, I put a bunch of bad words in there, and it could have, depending on the words I chose, it could say something extremely offensive. But that's not an ethical problem with the technology. It's just a goof. I don't think there's necessarily such a huge difference between that and this, other than if the content has that issue, it can't have unfettered access to children. Instead, my ethical concerns are in the predictive area, which has been the main focus of my career, and it has to do with civil rights. Is the model making discriminatory decisions? Because all of these operational decisions it's driving can potentially be very consequential. It's not just optimizing business and number crunching. It's governing. A model that makes predictions on a per individual basis is essentially a kind of a mini policy that's then either directly informing, maybe being the deciding factor for, or in some cases, literally, as I discussed, automating decisions. And if it's making decisions that discriminate based on protected class like race and religion, ethnicity, or is showing a certain kind of bias, and people call it machine bias. And there's a famous ProPublica article called Machine Bias that's very often cited, where the costly errors, and the model's going to make errors just like humans do. It's just hopefully it'll make fewer of them. It's not a magic crystal ball. But if the errors that are costly, such as that end up keeping somebody in jail longer or denying them credit or housing, happen with higher proportional frequency for certain underprivileged protected groups or racial groups, for example, than other, from one group to the other, that's a really serious civil liberties concern. So I've actually taken a lot of interest in that, written a bunch of op-eds in like the San Francisco Chronicle and the Scientific American blog. I put them all together. There's like 12 op-eds. If anyone wants to read my work, I put them all together at civilrightsdata.com.
We'll link to that in the show notes. One of the things I frequently say is that AI and machine learning models are perfectly designed to replicate human bias. And a lot of eyebrows go up when I say that from people who, either are naive about the potential harm that AI models can create, or just choose to turn a blind eye. What's your perspective on as a data scientist? How do we mitigate the impact of having human bias seep into these models, given that, to your point, they can make predictions that have significant implications on, for example, who dies, who lives, who gets loans, who gets educated, things that really have a dramatic impact on people's lives.
That's the central question to sort of what I'm obsessed about in this area. And I think what you said, that's perfectly designed to replicate human bias, is spot on. But actually, guess what? It's kind of good news. And follow me on this. By putting it on the table and quantifying and putting a spotlight on exactly what it is, what you're seeing is a quantification of the injustices that persist because of the world as it stands now. The historical inequities that put some groups in less advantageous positions than others. Now that manifests, and for example, it manifests in the proportional rates of those kinds of costly mistakes that I was referring to. To put that into technical terms, what we're talking about is false positive rates, where it says, oh, this person's high risk of committing a crime again if we release them for prison. This person's at high risk of not paying back their loan. In the case that those predictions are wrong, those are called false positives or false alarms. If the false positive rate's higher for one group than the other. So by quantifying, putting a spotlight on it, then now, instead of it's a bunch of people doing it inside the human head, you can see my head on the video. I know we're not going to video here, but my head is the ultimate black box, right? We can't see into each other's minds or brains. What we can do is quantify what happens when there's this transparency. And although models can be opaque to a certain degree, we do have transparency because we can record their activity. So this provides us the opportunity to adjust for those inequity and actually implement for social justice in the way models are deployed. Now, unfortunately, that does open a can of worms. And essentially, the way you would adjust for the difference in false positive rates would be analogous to affirmative action. I'm pro-affirmative action. I see those differences in false positive rates as a manifestation of historical injustice. I see the opportunity to adjust for it, but doing so means reintroducing the protected class. So then the model might be colorblind in the sense of not directly making a decision based on race, for example. But you do need to reintroduce the protected category, just the same as with affirmative action, to adjust for it. So it doesn't eliminate today's polarized kind of political debate around the topic, but at least it helps us look more concretely what the issue is and what we could potentially do about it.
You allude to a very important adjacent topic, which is that the owners or the developers of the algorithms and the data scientists who aggregate the data and wrangle the data into the models using the algorithms are, you could argue, as responsible for the output as whoever it was that generated the source data in the first place.
Mm-hmm.
I've advocated strongly on this show in the past for every data scientist or everyone who's going to be writing algorithms as a career, they should have taken at least one course on the ethics of AI, or maybe just more broadly on ethics before we give them the responsibility to create and push these algorithms out into the world. If you ruled the world, what would you do to build some kind of awareness of ethics or the sense of responsibility into the education that algorithm and data scientists are getting?
Well, now that you've given me rulership of the world, I'll take it. And here's what I'll do. First of all, totally agree that the buck has to stop with a human. The people on the team creating the model and deciding how it gets deployed. It's not just about the number crunching. It's about how it's used, how it's deployed, how those predictions are integrated and acted on. And they could be translated in all sorts of ways or tweaked. There is sort of the positive side, and these two things go hand in hand, which is that, hey, you say to the community of data scientists and machine learning practitioners and professionals involved, yes, there's a responsibility, but hey, wait, look at it another way. You've got an amazing opportunity to help with social justice, because the system that you're just one of a very small number of people who are putting the system in place that's going to affect millions of people in very consequential ways. So don't lose sight of that. It's very easy to get into your cubicle and your data table in that world. Very easy. I know from firsthand experience. But it's also not that hard to remind yourself, hey, let's take a broader perspective. So I'd say that systematically, the issue is that ethical standards that are proactive and pro justice are a bit hard to come by. And that a lot of this process for establishing ethical standards is frozen by the cosmetic needs of corporate PR. So corporations are always releasing statements that are very well worded and say, "Hey, we care about fairness and equitability and responsible machine learning, responsible analytics." Those words, in and of themselves, are only vague platitudes. They're subjective. They're not specific enough to define concrete action. Instead, the shift is to realize that when you're establishing responsibility standards, these ethical standards, you need to view it as a form of social justice. And this is going to be not up to corporations, it's up to individuals who work in corporations, obviously. People need to be proactive, take a stand. And in my case, as I mentioned, let's equalize those false positive rates. And let's make sure it's not literally discriminatory, and that the model, in the very least, is quote unquote colorblind in the sense of not taking as direct input something like race or ethnicity or national origin. Because if it does, it'll literally be making decisions in part based on those factors, which is the definition of discrimination.
Incredibly important point. The world is generating these quote first drafts, in your language, based on the values and the perspectives of a very small number of algorithm developers. And we as the public or as consumers using these generative AI tools don't appreciate how there is a layer of ethics and values implied, built into these systems. Now, I would add to your description of how it's slightly cynical, but we agree on this point that it's not just corporate PR, but it's corporate legal. If we look at this is all happening in real time, but since the New York Times sued Microsoft and OpenAI, just the impact it's had on ChatGPT, on what is able to be shared, well, that has a dramatic impact on how the world is consuming information, given the vast adoption of an LLM like ChatGPT. What's your perspective on, as a society, how can we improve awareness of the fact that a very, very small, a minuscule number of people around the world are making decisions about how the world consumes and learns from this corpus of information that's being fed into LLMs?
Yeah, I mean, that's a whole nother level of ethics as far as, what should it be allowed to learn from, including problematic copy and including copyrighted copy. Humans are allowed to be influenced by other creators and artists and such in general. Should a system be allowed to? How do you parameterize that? I don't think that the litigation is going to be neat and tidy. I think that it's a complex issue. And
Eric, I think that's the topic for the next episode when we have you back. How about that?
Awesome.
Hey, we're almost out of time, but you're not getting off the hot seat without answering one last question for me. As prep for this discussion, I got in the way back machine. I saw an episode that you published to YouTube, or maybe this was your alter ego, Dr. Data, who famously said in 2019, AI is BS. So given that, here we sit in 2024, and I want Dr. Data to give us one either maybe non-obvious or even controversial prediction about what's ahead for AI in the next 12 months.
Well, I think the hype's going to continue to grow, which is a mixed blessing at best. I think that there is mismanaged expectations, otherwise known as hype, which is a big problem, because when disillusionment sets in, it's costly, it's painful, it's no fun for anybody, and to a certain degree, at least, the baby gets thrown out with the bathwater. That is to say, the concrete value of use cases of both generative AI and predictive machine learning. The thing is that we're going to continue to have our socks blown off at least in terms of the demo amazingness, which is not a real word of generative AI that's doing video and doing multimodal and just new capabilities. There's a huge difference between being amazed and exactly how valuable it is in a concrete way for near-term applications. My concern is that the elephant in the room is there's no killer app. Now, I mean killer in the big sense of the word, the way people are conceiving of this human-like or seemingly human-like capability really becoming autonomous for certain large-scale tasks like humans can do. So I think it's misleading in that way, but it's still going to be amazing. The hype is already got a lot of momentum. It'll continue. That's a mixed blessing. At the same time, there'll be people who are being like, wait, this isn't how it's represented. So there's going to be consternation growing. But I think that the hype will outperform the consternation for the time being, maybe for another year or two.
We'll bring that one back from the way back machine next time we have you on the show.
Good. Oh, good. Yeah, we'll see if I got it right.
So many important topics. I know we just scratched the surface, but really enjoyed this discussion. Before we wrap up, where can the audience learn more about you and the new book and the great work that you're doing?
Oh, sure. The book's website is bizml, bizml.com. BizML, that's the new buzzword that I created with this book. That's the name of the 6-step business practice for running machine learning projects. And that website also has a page about me and any kind of links of any information you may want.
Great work. We'll make a point of linking to all those in the show notes. Well, Eric, this has been an absolute pleasure. I look forward to continuing the conversation. That is a wrap for this week on AI and the future of work. As always, we're back next week with another fascinating guest.